Welcome to my YouTube channel. In today's lesson, I will be teaching you a lesson on parallel circuit. So before we go any further into my lesson today, I would love to define what a parallel circuit is. So a parallel circuit is a circuit in which electrical components are connected side by side as shown below. So if we have an electric lamp here, another one here, and also an electric cell here, and a conductor here, another conductor here, another one 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 here. What we have come up with is a parallel circuit. For example, if we close the switch here, we are able to see our electric lamp giving out light because of an electric current flowing through them. So there are two concepts to learn from this type of a circuit. For example, if we close again, you are able to see the electric lamps giving out the light. So the first concept that we are supposed to learn from this lesson is that one, voltage is the same across components connected in parallel. So these cells here, according to the definition of a parallel circuit, these electric lamps here, according to the definition of a parallel circuit, they are connected in parallel because they are connected side by side. So in such an electric circuit, voltage is the same across the components connected in parallel. So the voltage across this electric lamp and the voltage across this electric lamp is actually the same. For example, in real life, if you got a voltmeter and connected it across this electric lamp and call this voltmeter V1, and you get another one, you connect it across this lamp here, you call it V2, then it means that the voltages that you are going to read from these two voltmeters are going to be the same. Alright, also if you got a voltmeter, you put it across these two and another one across the cell, it will be the same. The voltage that will be read across the cell will be the same as the voltage that will be read across voltmeter 1, and it will be the same as the voltage that will be read across voltmeter 2 and also across this another voltmeter here. The reason being is that voltage is actually the difference of electric energy of electric charges between 2 points. So what a voltmeter does, it actually tests the energy that electrons are coming with from this side and the energy that electrons are leaving with this side. So this voltmeter, even if it is connected across this electric circuit, it is able to know how much electric energy is going this way and how much electric energy is coming this way. Equally, this voltmeter here is able also to know how much energy these electric charges are going with this way and how much electric charge they came with. So it is the same as also this voltmeter here is able to know the electric energy these charges are carrying on this side and the electric energy that these charges are going with this side. So also equally the same as this voltmeter here is able to measure the voltage of electric charge on this side and also the voltage of electric charge as they go out of the electric cell. So in that scenario, you'll find that whatever this voltmeter is going to detect will be the same as this voltmeter, the same as this voltmeter. So what we mean here is that the voltage this here or this one is equal to the voltage that will be measured here and also equal to the voltage that will be measured here. Alright, so that is what basically the first concept to learn about this parallel circuit. So the other concept that we are supposed to learn here is that current is not the same across the components connected in parallel. So these components here which are connected in parallel, current is not the same across these components. The reason being is that as electric charges comes from this side, when they reach the junction here, they are dividing. Some electric charges are flowing through this lamp and some electric charges are flowing through this lamp, and you know that current is actually the rate of flow of electric charge. So the charges which are flowing here, they'll create a different current, and also the charges which are flowing in this other lamp, they'll create a different current. So this is why we are saying current is not the same across components connected in parallel. For example, if we were to put an ammeter here, then another ammeter here we are calling ammeter 1, another ammeter here we are calling ammeter 2, and also we label the current flowing through this ammeter here as current total or IT, and the current flowing through ammeter 1 we label it as I1 or current 1, and the current flowing through A2 we label it I2 or current 2. Then this means that the current which is coming from here, we call it current total, is the same as the current which is going there plus the current which is flowing here. So notice, because this current which is coming here, it's the one dividing here. So meaning if you want to find out what this current is, you can find it by adding this current going through ammeter 1 and the current going through ammeter 2. So basically this is what you are supposed to learn from such an electric circuit. So let's see how we can derive a formula for calculating total resistance for a parallel circuit. So what we are going to do here, let's say the resistor that is offered by electric bulb 1 is R1, and the resistance offered by electric bulb 2 is R2 or resistor 2. Then we are going to have a situation like this. So what we have done, we have replaced electric lamp 1 with its resistance, which we are calling resistance 1, and then electric bulb 2, we have also replaced it with its electrical resistance, which we are calling resistance or resistor 2. All right, so now what we should learn from this circuit is that using Ohm's law, which says voltage is equal to current times resistance, we are able to derive a formula for calculating the total resistance in such a circuit. For example, we know that current here can also be found by voltage divided by R. So since if current can be found by voltage divided by R, then we can easily replace this in this main equation here. For example, the current flowing through the circuit, the current we are calling IT, which is this one, can be found by this equation where we are saying current total going through this actually circuit can be found by the voltage or total voltage divided by total resistance, the resistance of the circuit here. So the voltage in the circuit divided by the resistance in the circuit, it will show us how much total current is flowing in the circuit. So also we can know the current which is flowing in this resistor here. So the current flowing in this resistor here, which is current 1, can be calculated by V1 over R2, meaning that the voltage across resistor 1 divided by the same resistor itself can give us the current flowing through resistor 1. Then also the current flowing through resistor 2, which is the same as this one, can be found by voltage V2 divided by R2, meaning the voltage across the resistor 2, which we are calling V2, divided by R2, which is resistor 2 itself. Now notice that these we can also replace them into this equation, because this IT, which is equal to V over RT, is the same. So we can equally get this expression and put it here, and also this expression is equal to this, and since this is equal to this, we can simply get this one and put it there, and equally get this one put there. So this equation now becomes V over RT is equal to V1 over R1 plus this plus here, then here, which is this one, we replace it with this one, so say V2 over R2. All right, so notice that we stated basically that voltage, total voltage actually in this circuit is the same as the voltage across the resistor 1, which is V1, and also the same as the voltage across the resistor 2, which is V2. So since these voltages are the same, then we can just equally replace these with one voltage that will represent all of them. So in this case, we'll just put the V here without equally or without adding numbers here. So say here V over RT is equal to V over R1 plus V over R2. Right, so we don't have space here, so let's move a bit here. So now what we are going to do here is to cancel out the variable that appears in all the terms. So in this term we have V, in this term we have V, in this term we have V. So how do we cancel out V here? So we multiply it with 1 over V, so that when we multiply it, V here becomes a denominator, and here, then we are able to divide. So when we multiply V with this, we'll have V over V RT equals V times this one, V over V R1 plus, then this one times this one will have V over V R2. Then we'll cancel out here the V. So this V and this V will go, this one and this one will go, this one and this one will go. So here will remain with 1 over RT equals, here will remain also 1 over R1, then plus here will remain with 1 over R2. So this one becomes our main equation for calculating total resistance in parallel circuit like this one. So let me know in the comment section if you are getting value from this video, and also give it a like. If you haven't subscribed, please consider subscribing so that you support this channel for doing these lessons. All right, so let's go to an example. So we are going to look at an example here, which is coming from an examination paper that appears in 2001. So the question is like this. So they are saying, this was actually question 8. So it is saying a circuit consisting of two resistors R1 and R2 carries a current of 2.0 amps as shown below. We have a circuit like this one, as you can see. So in this circuit we have a voltage here, voltage supply here, then we have resistor 1 and the resistor 2, and here we have current I2, which is equal to 0.5A flowing through resistor 2, and then we have current here, which is total current flowing through the circuit, which is I is equal to 2.0 amps. Then A, they are saying find the value of resistance R2. Then B, they are saying what is the reading of the ammeter. C, they are saying calculate the amount of charge which flows through resistor R1 after 10 seconds. All right, so this one I'm not going to do it. You can click on the video whose link is appearing here, so that you are able to be told how to calculate electric charge in a circuit, because I already did such a video here, so it's not the main focus of this video. Also here, calculate the amount of energy dissipated by resistor R1 after 10 seconds. No, we'll not do this one here. I'm going to do another video that is going to explain how to calculate the amount of energy given the values of resistance. Yeah, so let's look at how we are going to answer this question here. So again, they are saying A, find the value of resistance R2. So what will be the value of resistance R2 here, or resistor 2 here? So for us to be able to answer this question here, we must actually apply Ohm's law. All right, so Ohm's law states that voltage is equal to a current times resistance. So it is this resistance that we need to know here. So we'll make resistance the subject of the formula as R is equal to voltage over current. So in such a circuit like this one, notice that the voltage is the same across the resistors connected in parallel. So these resistors are connected in parallel because they are side by side. They are connected side by side. So meaning that the voltage that is flowing, or the voltage across these two resistors, is the same, whilst the current is different. So the current flowing through R1 and the current flowing through R2, they are different, but the voltage across these two resistors is the same, which is 6.0 volts. So for us to be able to find this resistance here, we'll just get the voltage across, which is the same, put it here, and the current flowing through resistor R2, which is 0.5, we put it here. So it will be R is equal to 6, which is the voltage, divided by 0.5, which is the current flowing through it. So when we divide 6 divided by 0.5, we'll actually get 12 ohms as the resistance. So the resistance of R2 is 12 ohms. So we can move to another question. Okay, so B says, what is the reading of the ammeter? So let's bring the circuit here. So they are asking us to find the reading of this ammeter here. So you know the ammeter reads current. So they are asking us indirectly to calculate current. So this is how tricky the exam can be. So now how can we calculate current here? So let's call the current flowing through ammeter A here is I1, because here they've told us this is I2, meaning there must be I1 which is flowing through resistor 1. If the one flowing through resistor 2 is called I2, then the current flowing through resistor 1 should be called I1. So let's create some space here. So remember, from our diagram that we started with, we said current is not the same in what? In parallel circuit. So the current which is coming here, when it reaches the junction, some current goes here and some goes here. So this is the equation where we said total current is equal to current 1, the one going through resistor 1, plus the one going through resistor 2. So notice that we are already been told, because this current which goes here and here, when it reaches the junction, it joins and it creates this current here, which is the same one which comes this side. So meaning we know the current I, this one is this one, and the current 2 here, it's this one. So now we can calculate what? Current 1. So what we can do here is replace. So this one comes there, and then this one comes here, so it becomes like that. So 2 is equal to I1 plus 0.5. Then what we are going to do is to make I1 the subject of the formula, or collect like terms on the same side. So this one will cross this side where we have another number. So it will be 2 minus 0.5 is equal to I1. So this minus comes about when this crosses on the other side. Since it is positive, then it becomes negative. So from there we are going to subtract 2 minus 0.5, which will be 1.5 is equal to I1. So it means that our I1 is equal to 1.5 amps. So meaning the current represented by 1 is by I1, or the one being read by the ammeter here is 1.5 amps. Okay, so let's go to another question. So I had to put some added questions so that I can add more concept to this lesson. So I added 2 questions. So question 1 says calculate the value of resistance or resistor R1. So you calculate the value of resistor R1. Then another one says find the total resistance of the circuit. So what will be the total resistance of this circuit? So let's begin with 1. So since what we want is to find the resistance of what? R1, and for us to be able to find the resistance of R1, we must use Ohm's law, which says V is equal to, or voltage is equal to current times resistance, and then this one V, which is the voltage across the components in V is the voltage in the circuit, and remember, voltage across components connected in parallel circuit is the same. Then I, it will be the current flowing in this circuit, in this resistance. Then R is the same resistance we are going to find. So let's make R the subject of the formula. So say R is equal to V over I. So we are going to replace, since voltage is the same, we'll get 6, we'll put here, and we know current we found here was what? 1.5, the current flowing through resistor 1. So say, because 6 divided by 1.5, then when we divide 6 by 1.5, we are going to get R as 4 ohms. So this resistor here is 4 ohms. So let's go to 2. So 2 says, so this resistor here is 4 ohms. So let's go to 2. 2 says find the total resistance of the circuit. So we need to find the total resistance of the circuit, or in this circuit. So remember, we derived this formula where we said total resistance is given by this formula, 1 over R. This one is total resistance is equal to 1 over R1, which will be R1 here, plus 1 over R2, this resistor here. All right. So we know, we have found out that this is actually 4 ohms. Okay, so this one we found it somewhere. So let's see. Yeah, so this one we found it as 4, this one as 12. So what we are going to do is to substitute. So we substituted R1 is 4, then R2 was 12. Then what we are going to do here is to add. So let's just push this one here. So we'll say 1 over R is equal to, so we find the common denominator. So this one is like a fraction, like mathematics that we do always. So in adding such a mathematics involving addition, or such fractions involving addition, we look for a common denominator in which 4 and 12 can go, so without giving a remainder. So in this case 12 itself, so say the common denominator is 12. So say 4 into 12, 3. 3 times 1, 3, plus 12 into 12, 1. 1 times 1, 1. Then we'll say 1 over R is equal to, add 3 plus 1, 4 over 12. Then we will make R the subject of the formula by cross multiplication. R times 4 will give us 4R equals, then 1 times 12 will give us 12. For us to remain with R here, we'll say divided by 4, here divided by 4. So 4 into 4, it will cancel, remain with R is equal to 4 into 12, excuse me, 4 into 12, it will be what? 3. So our answer here is 3 ohms. All right, so guys, we have come to the end of this lesson. If you learned something in this lesson, please give it a like, And if you haven't subscribed, please consider supporting the channel by clicking on the subscribe button. So guys, bye until I see you in my next video. Peace.